Hello everyone, today we are going to study the topic hyperconjugation and resonance. So starting with the resonance, what is resonance? In chemistry, we say it is a phenomena in which a molecule can occur in more than one type of Lewis structures. Phenomena in which a molecule can exist in more than one Lewis dot structures. How? Let's begin with the story of ethene and benzene molecule. We all know ethane is what? CH3, CH3, right? Ethene is what? C double bond C, H, 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 and H. With the theoretical studies of the bond length of carbon-carbon was made in case of ethane and ethene, it was found that the carbon-carbon bond length in ethane was 154 picometer, and same in the case of ethene was 134 picometer. So it was thought that the benzene, which we all know is what? Alternating double and single bonded 6 carbon structure, right? So it was thought that this CC double bond length would be 134 picometer, CC single bond length would be 154 picometer. But actually, when the experimental studies were done, it was found that the carbon-carbon bond length in case of benzene was 139 picometer. Why? Because it was found that this benzene molecule exists in more than one type of Lewis dot structures, which was the first one is this, the second one can be written as right. These two structures can be made. Why? Because the electrons of the pi orbital were moving, were delocalizing. So the phenomena of delocalization of electrons was being occurring in these type of pi bonded structures. These two structures are known as resonating structures and the intermediate, which actually shows what type of a molecule is written like this. The circle represents the delocalization of electrons, from all of these carbons, in between all of the carbons. This structure is called resonance hybrid. So this resonance hybrid is the actual structure which depicts the actual properties of the benzene molecule. None of the single structures between these two, or the resonating structure, is able to decipher the actual properties of the molecule. This structure cannot fully exhibit the properties of benzene. This structure cannot fully exhibit the property of benzene, but this structure does fully exhibit the properties of benzene. Why? Because the pi bond are delocalized in between all the 6 carbon atoms. So resonance is what? It is this concept that the molecule can exist in more than one Lewis dot structures, and we all know if we have the delocalization of electrons, this is being occur for what? Molecule does all the necessary things. We all do all types of things for what? For stability. So this phenomenon is also occurring for the stability, because the pi bond is being, the pi electron cloud is being distributed amongst all the 6 carbon atoms of the benzene. So the electron cloud is equally distributed. There will be no such places that at certain places the electron cloud is high, at certain places the electron cloud is low. The electron cloud is equally distributed. So the equal distribution of electron cloud does lead to the stability. Okay. So more is the number of resonating structure, or more is the resonance, more is the resonance, more is the stability. More is the resonance, more is the stability. Understood? Now let's begin with the hyperconjugation. See, this hyperconjugation is nothing but an extension of resonance. Hyperconjugation is nothing but an extension of resonance. How so? In hyperconjugation, see, in resonance we saw there is a delocalization of electrons from the pi orbitals. There is the delocalization of sigma orbitals to p orbital of the adjacent atom. Empty or partially filled p orbital of the adjacent atom. That is why it is also called sigma p orbital resonance. See, we can take the case of carbocation CH3 CH2 plus. Okay, we know a carbocation, this is a primary carbocation, so it is unstable, we all know. So what will happen? The CH bond will break. The CH bond will break. The H positive will be the resultant. The 2 electrons thus will be given to the carbon, which will be equally distributed amongst themselves and form a C double bond. This means the stability of the molecule is being increased. All these phenomena are occurring for the sake of stability. Similarly, any of these hydrogen can get cleaved. Let us say, if we begin with this, let's label this as 1, 2, 3. If we cleave the 1, we will get H positive. This is for the 1. If we cleave the 2, then we will get H positive. Or if we cleave the third hydrogen, H and the H positive. Okay. So this hyperconjugation can occur in carbocation. It can occur in free radicals. It can occur in alkenes. So carbocation will be having empty p orbital, or vacant p orbital. These two will be having partially filled p orbital. Okay, this is also called no bond resonance. Why no bond? Because in case of hyperconjugation, we see there is no actual movement of the bond. There is no actual movement of bond. See, This was a sigma orbital. I can represent this like this. This was a empty p orbital. This is for the case of carbocation. So what will happen? This is empty, that is why it is bearing a positive charge. Okay. The electron cloud will get shifted towards the p orbital. This is the sigma orbital, this is the p orbital, that is why it was called sigma p orbital resonance. And in case of no bond resonance, why we call it no bond resonance? Because there is no actual movement of the bond. The hydrogen is being cleaved and the bond formation is occurring. There is no actual movement of bond. So it is also called no bond resonance. What is the difference between the two? Simple difference. Resonance involves delocalization of electrons of pi orbital. Okay. Whereas in case of hyperconjugation, it involves delocalization of electrons of sigma orbital to the empty or vacant or partially filled p orbital of the adjacent molecule. So this was the basic concept of hyperconjugation and resonance. Thank you.